there are three ways that I have classified the random process, but the important that we have to study is based on the statistical properties. Means when we look at the random process, when fixing the time, we get a random variable. So vertically, when we see or how this vertical averages are equal to the horizontal averages, means how they are related. If they are related, then so they are based on the what properties, right? Averaging. So today we will write some definitions. I will not open the PPT because I feel like that is boring. So let me go with this one. So first of all, make it clear that you have you know the notations. Otherwise, it will make a problem. I have talked enough about this notation and all those things, but now see this what I am trying to say now. Till now we have seen only one function of only one random variable, but when I have two random variables, right? So the question is what how many random variables I can define on the same sample space. The answer will be I can define infinite random variables on the same sample space, right? So in case of random process, we are already getting infinite number of random variables, because whenever you sample the process, whenever you fix the time in random process, you get a random variable. So whenever you are fixing the time in random process, you are getting one random variable. So since time can be extended from minus infinity to plus infinity, so by definition, random process contains infinite random variables, one for every time instant t. So whenever you fix the time, you get a random variable. So there are infinite random variables. So you take each one of these random variables and in the sorry, I got disconnected actually. Light was off. Okay, so I think there is no problem with this first line. Anybody is having any problem with this line? See, please speak something, right? Yes or no. Otherwise, I will move further. So there are infinite random variables I can have from the random process. Whenever I fix time, whenever you take t equal to uh, some time, you will get one random variable. So in definition, by the definition, I can say the random process is a collection of infinite random variables. So one random variable for each instant of time t, and time can be from minus infinity to plus infinity. So there will be infinite random variables. Whenever I fix the time, I get a random variable. So or sample the random process. So observing or sampling the process is something like what? It's like at what time you are observing the process, or sampling means what? It's just you get a random process, and when you sample it means what? At what time you are taking the samples. So both meaning is same. So if you observe the process or if you sample the random process, let's say at n time instance. So this is capital N time instance. Let's say t1, t2, tn. So whenever I fix time, I get a random variable. So the corresponding random variables will be n random variable. So n time. So if you sample the process at n time instant, you will get n random variables. That is xt1, xt2 up to xtn. I told you that when this notation can be written as what x suffix t1 or x suffix t2 and x suffix tn. Whichever the notation you like, you can use. Okay, so this is what the random variables are. So there are n random variables. I know how to
Sir,
do.
excuse me, sir.
Yes.
Sir, you are serving for one instant only one random variable for only one outcome. Is that right? Or because for each outcome we have one random variable for fixed time.
No, no. If you fix the outcome, you get sample function, not random
No,
variable.
no. For fixing the time, we
You're
get
fixing.
uh, we have n number of outcomes. So for if we fix the time, we will get one outcome for one random variable.
If you
That I
fix,
was saying.
I'm not saying that I am fixing the time. I'm not fixing the omega. I'm not fixing the outcome.
Okay.
You're getting confused here. Whenever you get confused, just go to this point. Head, tail. Head is a one waveform. Tail is one waveform. So this is x of t. These are the two waveforms, x1t and this is x2t. Head, if head occurs, this sample function will be the output of random process. If tail occurs, this will be the output of random process. But when you fix the time, you get this value. I'm not fixing omega outcome. This is random variable.
Yes, yes,
Is this clear now?
yes, sir.
ये ऐसा मत करो यार अभी, है ना, इस टाइम पे, ठीक है? So don't get confused. Whenever you get confused, you draw this diagram and check this what you're getting, right? So at the beginning you may feel like it's difficult, but it's very simple if you go through this one, right? Okay, so I'm not fixing omega, I'm fixing time. So whenever you fix time, you get random variable, right? Because this
Yes,
xt1
sir.
can this value or this value depending on the outcome. So this is a random variable. So there are n number of times. When you see the process at n times, so you'll get one random variable for each time. So that is xt1 up to xtn. Now, in the unit number 3, part 2, I have discussed the last numerical. In that numerical, I told you that when you have only one random variable, so it's just a function of one random variable, and you find the DC power of that random process at that time. Let's say you observing the process at t equal to t1. So you are getting one random variable. So by getting this one random variable, what you are going to interpret, right? Or what you are going to do analysis on that one random variable. So you will say, I will find DC power. I will find the mean square value, that is total power. I will find the AC power. So I will say that when the question that just see this thing, right? Random process, when you fix the time, what I am asking here, I can ask the question like what is the DC power of random process when you sample that process or observe that process at t equal to t1? Or it may be like, what is the total power of that random process when you observe the process at t equal to t1? What I mean by that one, this all quantities are dependent on time now. So time changes, the power of random process changes, because anytime you change the time, you get a new random variable. So these all n random variables may not have the same amount of power, right? So those questions can be answered if you see random process at only one time. At only one time. Are you getting my point? Is this point clear? Is this point clear? यूनिट
Yes,
नंबर
sir.
पार्ट 2 में ये वीडियो लाइक एक्सप्लेन किया है मैंने वहां पे. So if you fix the time, you get only one random variable, and from one random variable which kind of questions you can answer for that random process is what at time t1 I can find the total power of random process, I can find the total DC power of the random process, I can find the AC power of that random process at that time t1. But this will give you only what the power, but I want to do more analysis on this random process, not only one random variable. So I want to take two or more random variables. So let's say I will take two random variables, xt1 and xt2. So I will Now sample the random process at t equal to t1, and next time I will sample the process at t equal to t2. So I will get two random variables. So with the help of two random variables, what I will check? See, what we will do is how the values are changing when you change the time from t1 to t2. How the values are changing means what? I can get answers like what is the relation between the values changing from time to time. That answers can be given if you see two random variables at a time. Is this point clear? Is this point clear? So if you want to check how the values are changing, if you change your time t1 to t2 like this. So now if I have the same random process and now I will sample it some other time. So I will see this is my values. So at time t equal to t1, when head was there, then this was the value. At time t2, I get another random variable, and at time t2, head was mapping to this value. So I can see that how the values are changing if I see two random variables at a time. This value and this value, you can see this head was before it was at equal to t1, it was this value. At equal to t2, it is this value. Tail was this value at this time, and at equal to t2, its value is this one. So what is the meaning of that? That what are the means what different analysis I can do if I see more than one random variable at a time. So that is captured by the joint PDF, right? So if you have only one random variable, we call it xt1 when it takes x. When you have two random variables, I will talk about joint PDF. Joint PDF is something what when you look at the more than one random variable at once, right? So I can have more than one random variable. So those PDFs joint PDF. So joint PDF meaning is very simple. You just see this how I define the PDF. If you go to random variable, right? I'm not talking about this one, but let's say I have this one random variable x. So what is the meaning of that? This is the PDF of one random variable when x, capital X, takes the numerical value small x. That is the definition of this. When I say two random variables, right? When I write two random variables, I have fx comma y and xy. I can have three random variables. So I can have three random variables like what? X, y, and z. When capital X takes the value of small x, capital Y takes the value of small y, and capital Z takes the value of small z. So what I'm saying what whenever you fix one time you get one random variable. So in case of this is what one random variable, and from that you can find only what DC power, AC power, and total power. You will not be able to see the relationship between the random variables, because unless you take more than one random variable, how will you check the relationship? How these two random variables are related to each other? So that can be captured if you take more than one random variable and you find the joint PDF. Joint PDF is something what we call it joint PDF. So the name is joint PDF, but now it is of two random variables. This is also joint PDF, but it's of three random variables. So in case of in our case, this is x, y, z, x, y, z, x, y like that. But in our case, I am getting two random variables when I sample the process at two times. So this will be like this one, and this is something like x12 and x2. This is the notation that I am going to use, right? So this is fairly simple. I hope this is understood by everyone that how this joint PDF is occurring, right? So xt1, xt2, x1, and x2. This is what the meaning of this, right? So there comes the independency, how this means they may be independent, that like when you sample the process, any two random variables are independent of each other, independent to each other. So that is we are going to each other to be very fairly simple. It's not I don't think it's a new thing, but it's just generalization of what I will take two random variables and talk the same thing. So here we are talking about one random variable taking the small x. Now we are talking at the same time when capital X takes the small value x and capital Y takes the small value y. So this is the meaning to this. Now I will I will go with simple notation and do that one. I will go to probability. Can anybody tell me what is the definition of probability A intersection B? Intersection is something what? And. It's AND operation. How you write it? P of A times P of B given A. Whenever I get two random variables, I will expand this by like this. P of A intersection B is nothing but P of A into P of B given A. Or you can say something P of B times P of A given B. Right. So similarly, this PDF also follows the same rule. When you say X and Y, capital X takes the small value X, capital Y takes the small value Y. So I can have this is fxx and second will be fyy given x and this will be y given x. So this is called conditional PDF. Like this is called conditional probability. So this is called conditional probability and this is called conditional PDF. Right. I can have n numbers of things to do like A intersection B intersection C. You just think like this is A and B and C. Probability that A is happening simultaneously, B is happening simultaneously, C is happening. All together, all these things are happening. Then what will be the formula? So you can just think like this comma is nothing but and, comma, intersection, and this and. These are same things, but we define it like what? X, comma, Y, right? We don't write intersection all the time, but we'll write just comma. Here it is A intersection B, but sometimes people also write it like A, comma, B, right? So comma is something what we are using for intersection. So you can generalize it again. How I can do that generalization? It's very simple. You just think on this one. You first do what? You just think like this is two events and I can assume this is one event. This is only one event for me. So I will write what? P of A times P of B intersection C given A, because this is one entity. So you can just assume this is one thing. So this A and then into P of B given A. So instead of B, I have B intersection C. So I will write B intersection C given A. I can again what use this one. So how you write P of B intersection C? So this is what P of B, because it's in the conditional environment. So it will be P of B given A and P of C will be given A and B both. So what is the meaning of that? You look at the total probability of A, then you see the conditional probability of B given A, and then you write probability of C given A intersection B. So this is just a multiplication rule that it follows, right? So I hope this is clear. Sometimes people try to write it in terms of tree diagram. So I can have like what? At the first thing, I will check only A is happening or not. So if A will happen or A will not happen, then I will check B is happening or B is not happening. And in this case, also again, B is happening or B is not happening. Next thing will be what? So that is what when A happens and B both happens. So this will be A intersection B. This will be A intersection B complement. And then I can have C happening or not. When C happens, it means this is A intersection B intersection C, because this is the path that is following this one. So first A happen, and then if A happen, what is the probability that B happen? That will be A intersection B when both A and B happens, and then it is what? When A, B, C all together happens. So you can write this as a getting probability, getting A is nothing but probability of A, getting B given A is nothing but B given A. When A happens, what is the probability of B? That is nothing but P of B given A. When A and B both happens, then it will be C given A intersection B. And if you see, what is the probability of A, B, C all together happening is nothing but just multiply the probability in the branch. That is P of A times P of B given A times P of C given A upon B, A and B. I hope if you draw this tree diagram, you will follow this multiplication rule. It's fairly simple. It's fairly simple. So all together happening का जो probability निकाल रहे हैं अपन, वो कैसे निकाल रहे हैं? हम लोग सिर्फ probability हम लोग चेक कर रहे हैं A, what is the probability of A, And then we are talking about when A happens, what is the probability of B? And then when A and B both happens, what is the probability of C? And all together we are multiplying them to get this definition of P of A intersection B intersection C. I can get the same thing for A intersection B intersection C intersection D. I can generalize this formula for any number of random variables or any number of probability. So same goes here. If you have X, Y, and Z like this, where is that? X, Y, Z. So this formula will be what? Fx. You look at the total PDF of X, then you look at the PDF of Y when X is given. So that will be this one. And then you finally get the Z when X and Y both happens. So this is comma now. It's not intersection, but it's a comma now. And then it will be Z, small z, given X takes small value of X and Y takes small value of Y. So this will be the formula for this one. So you can generalize for n numbers of probability of this PDF. So same goes here. Instead of X, Y, Z, I have XT1, XTN. So you just think on this one. This is one random variable X, this is Y, this is G, and so on and so forth. So XT1 is one random variable, XT2 is another random variable. So I have okay. I got disconnected again. Light goes off here in college. Okay, so I hope anybody is having any problem in this notation. Say yes or no. Otherwise, we will move further. Yes. Anybody is having any problem with this notation for joint PDF?
No, sir.
Okay, so it's fine, right? So sometimes some books write it like this one. They explicitly mention this T1, T2, Tn. Definitely, this PDF will depend on it. This n random variables are taken at what n times, right? It may be 2 seconds, 3 seconds, 4 seconds, 5 seconds, up to n second. It may be like starting from 9 second, 10 second, like that. So this PDF, this joint PDF is in general as a function of time T1, T2 up to Tn. So there are n times. So this PDF will depend on those n times. So this PDF will depend on, suppose you are taking two random variables and finding the joint PDF. So I can take two another random variables and like this, and this will be, let's say, T3 and T4. So the joint PDF of these two random variables will be different from the joint PDF of these two random variables in general, right? They may not be different, but in general, it is what the thing is, right? So the PDF, joint PDF, it will depend on this time, at what time you are taking the PDF, right? A joint PDF or random variables. So this is why they write it what? Instead of writing this long notation, what they do, they simply write X. So they call it random process. And, or you can say this is just a random variable, which x1 takes the small value x1, x2 takes xt2 takes the value of small value x2 up to xn. So this will say this is joint PDF of n random variables, and they write this t1, t2, tn at what? In the bracket. So they say explicitly that this PDF is a function of time as well, that is t1, t2, tn. So which notation you want to use, you tell me, so that in further lecture we will use that notation only. So both notations are same. Which notation? First one. So, okay, no problem. But make sure that when you are getting this point, this PDF is always going to depend on this T1, T2, Tn, right? So this is what this one. So in general, this is a function of time T1, T2, T up to Tn. So this is the meaning of this. You can generalize it. So let me generalize this formula, or let me write what? Let me write the meaning of that, so that I can incorporate conditional PDF as well. Let me just delete this one. So we will use the first notation and we'll stick to that notation only. So in book you may find the second notation, which will also true. So let us write the definition of this. So what is going to be? It will be fxt1 when this first random takes the value of the small x, and then you condition. So this is what xt2 given xt1, and this will be x1. So this is x2 given x1, and you can generalize it for n random variables. So I can go on multiply this PDFs up to n, and finally I get what x tn given xt1 comma xt2 comma up to xtn minus 1. I hope this is clear. And this is what xn given x1 x2 up to xn. So I've just generalized that formula of conditional PDF, how these are related. This is what the meaning of that one. So this is one random variable, then you fix this random variable and talk about the second random variable, and you go on, and then you n minus 1 total random variables are given. Find the PDF of nth random variable, that is xtn, and that can be given by xn given x1 comma x2 into comma xn, and these all PDFs are multiplied to get what joint PDF. One important thing is what when the PDFs when the random variables are independent. When the random variables are independent. So when you say the random variables are independent, what do you mean by that? Can you tell me what is the meaning of this? What is the meaning of independency? If two random variables are independent, suppose x and y are independent, what do you mean by that? Yes, if x and y are independent, what is the meaning of this? Physical meaning क्या हो सकता है? Can I say this x does not carry any information related to y? So what is the meaning of this? That if you tell me y has occurred, I will not change my belief about x. That is the meaning of what x does not carry any information related to y. It is just the other way also. Or y also does not carry any information related to y. So that's why in that sense they are what independent. If you say me there are two random variables, suppose means what this is something what just winter season, or let me say just winter season, right? So winter season में अपन एक shop है अपने पास, we got a shop, and this is just a winter season, and so this is winter season. In this winter season, if you say the number of sweaters sold and the numbers of per day, let's say per day, and the number of cold drink sold per day. What do you think? Though it is whether it is winter or not, but just assume this: what number of sweaters sold per day and number of cold drinks sold per day. What do you think? Are they related or not? So I'm just mapping it to random variables. So per day I'm counting the number of sweaters sold per day, and same thing I'm just looking at the number of cold drinks sold per day. So what do you find? Is there any relation or not, or are they independent?
No, so no relation between them.
Why there is no relation?
It can be related with the winter season or some that season, but
Yes, I'm talking about this July to October to December, suppose January, or it may be summer season. Yes, are they not related? If this is winter season, then number of sweaters ज़्यादा बिकेंगे, मतलब कोल्ड ड्रिंक कम बिकेगा उस दिन. Yes or no? Yes or no? So you are you not able to see that when cold drink कम है तो स्वेटर ज्यादा है, स्वेटर कम है तो cold drink ज्यादा है. So are they not related? So if you tell me that आज cold drink ज़्यादा बिका है, then I will tell what yes, इसका मतलब है स्वेटर कम बिका होगा. There is chances that sweater will be sold lesser than the cold drink, means very less, because today cold drinks I sold is very in a large amount. So it means that when sweaters जो बेचेगा मतलब जो भी सेल करेगा, that will be small number, right? So they are related, but they are negative correlated. They are negative related. Means what? If cold drink is low, then sweater is high. Sweater is low, then cold drink is high. So there are some cases like what you can take this Z, suppose. Let's take Z and let's assume something what number of let's say samosa, right? So this now you can say this X and Z are independent. Means what? स्वेटर का कोई लेना देना नहीं है समोसे से. करेक्ट. गर्मी में भी समोसे खाते हैं लोग, ठंडी में भी खाते हैं, जहां मन लगा तब खाते हैं. सो इट हैज नथिंग टू, इफ यू टेल मी आज समोसे इतने बिके हैं, कैन यू टेल मी something about X? So you will say I will not say anything about sweaters. I cannot say anything about sweater because the samosa giving me the information of more number of samosa sold this day, any particular day, on any particular day. It will not tell me anything what that sweaters should be sold more or less, because they have nothing to do with them. So X and Z are independent, but X and Y are highly dependent, right? So at least this point should be clear, that independency meaning kya hota hai, right? So one thing is independency, and one thing is called uncorrelatedness. अभी इंडिपेंडेंसी मतलब क्या होता है एंड अनकोरिलेटेड मतलब क्या होता है? इट्स अनकोरिलेटेडनेस इज नथिंग बट इट्स अ लीनियर इंडिपेंडेंसी. Linear independency means what? Suppose you have two random variables, x equal to cos theta, so theta is random variable, so cos theta will be random variable, y equal to sin theta. If I ask you X and Y are X and Y are related, yes or no? Can you find X if Y is given? Can you find Y when X is given? Yes. Yes. If sin theta is known, can I find cos theta or not?
Yes, sir.
Definitely, right? Because I know the relation that x square plus y square is making 1. So I can write y as a function of x, or I can write x as a function of y. So they are related, but are they related? Are they related linearly? Are they related linearly? Can I write y as a linear function of x? Is it a linear function? Is it a linear function? Square root 1 minus x square. Is it a linear function? Is it a linear function? Say something. It's a linear function. Can you write it in terms of mx plus c? Is it mx plus c form?
No, sir.
इतना टाइम क्यों लग रहा है? अरे इस पे कितना प्रॉब्लम है? Y equal to square root of 1 minus x square. It's not a linear function of x, but they are dependent, because when you say x, I will tell you y. When you say y, I will tell you x. Are you getting my point? Are you getting my point? Are you getting my point?
Yes, sir.
So
Yes, sir.
it means that when this x and y are linearly independent, yes or no? They are what? Linearly independent, because you cannot find x as a linear function of y, and you cannot write y as a linear function of x. But they are not independent. But not independent. So I hope this makes sense. Uncorrelatedness is the rather is what lesser restricted condition. You can say independency. What independency is something what in any sense they should not be dependent. Are you getting my point? So independency is more restricted condition. Two random variables can be linearly independent, but they may not be completely independent. So restriction, so that is captured by this one. So uncorrelatedness captures what? That if they are linearly independent. Completely independent के लिए condition क्या होना चाहिए कि y cannot be written as any function of x, any function of x. The matter, the time whenever you can write y as a function of x, then they are not independent. Then they are. You see here, uh, if you can write this y as a linear function of x, then they are also not linearly independent, right? Is this clear? So हमारे पास दो ऑप्शन है इंडिपेंडेंसी चेक करने के लिए. एक इंडिपेंडेंसी मतलब completely independent. X is not telling you anything about y, y is not telling anything about x. That is called completely independent. These two and are completely independent. Uncorrelatedness is what something. It is rather less restricted condition in the sense that we are just talking about linear independence. Are they linear independent or not? So meaning of that independency and uncorrelatedness. So uncorrelatedness is just checking what are they linearly independent or not. If they're linearly independent, I will say they are uncorrelated. But independency is something what? See this point. They are linearly independent, but they are not independent. So linearly independent को बोलने के लिए क्या बोल दिया उन्होंने? Uncorrelatedness बोल दिया कि they are uncorrelated, but they are not independent. So any two random variables, or you can say they can be uncorrelated. So uncorrelatedness does not imply independency, complete independency. So independency means what? If you say independency means it's a complete independency, unless you tell me it's linear independency or not. So the two random variables can be uncorrelated, but they may not be independent. And the other way, if they are independent, then definitely they will be uncorrelated also. Yes or no? So this is the main thing. Yes or no? Is it true or not? Yes. बोलिए भाई जल्दी. यहाँ पे एग्जांपल ही दिया मैंने. यहाँ पे टू रैंडम वेरिएबल्स ये लिनियरली इंडिपेंडेंट हैं, बट दे आर नॉट कंप्लीटली इंडिपेंडेंट. सो कंप्लीटली इंडिपेंडेंट को अपन इंडिपेंडेंसी बोल रहे हैं और लिनियर इंडिपेंडेंसी को अपन अनकोरिलेटेडनेस बोल रहे हैं. सो दिस टू रैंडम वेरिएबल्स आर नॉट linearly dependent, means they are linearly independent, or they are uncorrelated, but they are not independent, right? So x and y are not independent. So but if they are independent, then I'm saying that one, that x cannot be written any function of x. So if you tell me x, I will not be able to find y. That is the meaning of complete independency. So if you cannot write y as a function of x, then there is no chances that you can write as y as a linear function of x. Yes or no? Yes or no?
Yes, sir.
So uncorrelatedness does not necessarily imply independency, but if they are completely independent, then it means that when they are also uncorrelated. So that's why I'm saying this one, this independency, complete independency or independency is a more restricted condition than the uncorrelatedness. This is what I've just said this now, how this independency works and how this, what is the importance of this independency. So if you say me, if x and y are independent, so you write what fx comma y, x, y, and you write the definition like what fx, x, and you write what fy given x and y given x. So if you are saying me that one, x is not carrying any information, any information related to PDF. So my PDF, which was before before knowing what x is, after knowing x is, I am not going to change my belief about y. This PDF about y. So this will be what fx x, fy y y given x will be just this one. So this is the main idea of this independency. So conditional PDF becomes just the simple PDF. I hope this makes sense, because x is not carrying any information related to y. So given x or not given x, the PDF will be same. right? But in this case, if you tell me cold drinks ज़्यादा बिका है, then definitely I will change my PDF award sweater. Yes or no? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
So अगर आपको PDF पता है, मतलब कोल्ड ड्रिंक अगर बोलोगे आज के दिन ये इतने बिके हैं, then definitely I will go and change my believe about PDF अवार्ड स्वेटर. जो भी पहले में मैंने डिसाइड किया होगा वो तो ठीक है, बट जब मेरे को बोलोगे आप कोल्ड ड्रिंक आज ज़्यादा बिका है, 2000 कोल्ड ड्रिंक बिक गए हैं, then definitely I will go and change my belief about this sweaters, that I will change my belief about why. See this, if I flip a coin, independency is very simple to understand, right? Flip a coin 2 times, right? तो आप क्या बोलते हो, पहले में हेड आ सकता है या तो टेल आ सकता है, सेकंड में हेड फॉलोड बाय हेड हो सकता है या हेड फॉलोड बाय टेल हो सकता है. Same here, tail followed by head, head followed by tail. So if I tell you in the first toss head was happened, will you change the belief about second time? So suppose that the probability of H is small p and probability of tail will be 1 minus p. So if I write what is the probability of getting H, what will you say? What is the probability of getting head in first toss? What is the answer to you? What is the probability that head in first toss? What is the probability?
1/2.
अरे 1/2 कहाँ से आया, मैं p बोल रहा हूँ तो इट्स नॉट अ फेयर कॉइन, इट्स स्मॉल p नो. क्यों आप 1/2 कर रहे हो? मैं बोल सकता हूँ ना मेरा कॉइन फेयर नहीं है, हेड आने की प्रोबेबिलिटी कम है, वो 1/3 है ओनली, तो इसलिए मैंने यहाँ पे स्मॉल p लिखा हुआ है ना. इसको आपको दे रहा हूँ क्वेश्चन और आप आंसर दे रहा हूँ, आप आंसर कुछ हाफ बोल रहे हो.
Okay, sir. P.
ओके, व्हाट इज द प्रोबेबिलिटी ऑफ हेड इन सेकंड टॉस? पहली बार फ्लिप किया मैंने, तो फिर सेकेंड बार फ्लिप किया. सेकेंड बार जब फ्लिप करोगे तो फिर भी पी होगा या कुछ और होगा? अरे
P होगा.
P होगा, राइट? सो इट इज व्हाट
Yes, sir.
द दिस टॉसेस आर इंडिपेंडेंट, मींस फर्स्ट टॉस में क्या आया कोई फर्क नहीं पड़ता, सेकंड टॉस में हेड की प्रोबेबिलिटी क्या होगी. आर यू गेटिंग माय पॉइंट? फर्स्ट टॉस डज नॉट कैरी एनी इंफॉर्मेशन रिलेटेड टू सेकंड टॉस रिजल्ट. सो आप बोलोगे फर्स्ट टॉस में हेड आने की प्रोबेबिलिटी क्या है, पी. मैं बोलूंगा सेकंड टॉस में हेड आने की प्रोबेबिलिटी क्या है, मैं बोलूंगा फिर से पी, बिकॉज फर्स्ट टॉस में कॉइन को फ्लिप किया, हेड आया, टेल आया, इट does not going to change the belief about second toss getting head or tail. It will be still p and minus p. So that's what I am saying this one. That's what I am saying here. This independency means what? What is happening, it does not matter with what is going to happen, right? What has occurred does not change your belief about the what is going to happen. So first toss में आपका हेड आया, टेल आया, कोई फर्क नहीं पड़ता मेरे को. सेकंड टॉस में मैं फिर से probability of p क्या बोलने वाला हूँ. So this is probability of p in first toss head 1 I've written. Probability of getting second toss result in head will be again small p, because I don't have to do anything about the first toss when I'm doing second toss coin. I'm doing the tossing in second coin. So these two tosses are independent. So that's why in the if you see the numericals, they write independent tosses of a coin. So they write like two independent tosses of a coin. So what you are saying is this one, that what is the probability that getting head in second toss, given that first toss result is head, what you will find? It will be same as pH2. Yes or no? Yes or no?
Yes, sir.
Definitely. So this does not carry any information related to the what is going to happen. So if you tell me first toss results in head, if you tell me first toss result in tail, then also I will take this as a pH. I will take this as a P only. So telling me about first toss result, I'm not going to change my belief about head and tail toss, right? So these two events are independent. Same here, this is what independency meaning. So if you say me this P and A and B are independent, so B हुआ है नहीं हुआ है कोई फर्क नहीं पड़ता, because this will be exactly same as PA. So in that case this becomes this formula. So if you see this P intersection B, if you these two events are independent, so I will say this is PA times PB. So this is what the formula came out. If what, if A and B are, if A and B are, if A and B are
Independent.
independent, but if they are not independent, I will write that what, definitely my this what B happening depends on A, so this will be formula there. But if they are independent, this becomes this one, because independency says that when this P of B given A has to be PB. So there, if you have, kahan chala gaya main, where I'm there. Okay, so if they are independent, if they are independent, if independent, if all things are independent, then I can write the joint PDF as just the multiplication of all individual PDF. Yes or no? If they are independent. So if they are independent, nothing to do with what conditioning, I can just take the individual PDF and I will just multiply them to get the joint PDF. In most of the cases, we will be having independent random variables, right? So this independency simplifies your analysis, right? Simplifies your analysis. So this is what called as joint PDF. डाउट्स हैं तो पूछिए, एक दो लोग ही हाँ ना बोल रहे हैं. I am not discussing some big things, but I am trying to simplify the things for you. You have read it, आपने पढ़ा है पहले ये. It's not the first time you are looking at the independency or something. Is this clear now? बोलिए. बोरिंग हो रहा है तो मैं बंद करता हूँ. Is this clear now?
Yes, sir.
Okay. So this is what the PDF is. Do you know about CDF? तो इसको किसको बताना पड़ेगा मेरे को. Do you know about CDF? These are not related to random process. These are related to random variables, which you should have studied it in your previous year courses. I don't have too much time, right? Okay. What is CDF? CDF क्या होता है? CDF is called as cumulative distribution function. So a PDF is not same as probability, but CDF has a unit of probability only. So CDF is defined as what? It is denoted by capital F. So let me take first one random variable. So one random variable, by the definition, its definition is what? Probability that random variable takes the value less than small x. It means what? We are talking about what? If I get PDF like this is a PDF, and suppose this is my x1 and this is my x2. If I ask you, this is a PDF, so this is PDF. If I ask you what is the CDF, so probability that x is lying between x and x1. So this is the probability. So probability has to be area under the curve from x1 to x2. कोई problem है इसमें? इस definition में? So this will be x1 to x2 fxx dx, right? So probability that random variable is between x1 to x2, it has to be PDF area from x1 to x2. It's fairly simple. So the area has to be calculated in this region. So this is the definition, by the definition. So if you ask me what is this one, you are asking me simply that when a random variable is, it should not be greater than x. So I can write it also like this. It can be from minus infinity and go to x. Any problem with this definition? Any problem with this definition? This is same as this one, yes or no? Yes or no? So we are talking about probability of random variable taking is smaller than x. It should not be larger than x. So it can be any smaller than x, any value which can be smaller than x will be okay with me. Yes or no? Are these two same? No, these two are same. No. So by using this definition only of probability, how to find how this probability and PDF are related, I can go from minus to x, and this will be fx x dx. So CDF is nothing but just the integration of PDF starting from minus infinity to x, or you can simply just remove this. You can, if you assume this minus infinity is 0, because when you start your PDF, what is the area if you start from minus infinity at this point? It will be 0, right? Because you are starting from minus infinity, right? Yes or no? What is the probability of if you go very far minus infinity? If you go up to, if you take x equal to minus infinity, what is the answer there? If x is equal to minus infinity, if you take x equal to minus infinity, so this is the integration from minus infinity to minus infinity. What the answer will be? 0,
0.
because both the limits are same.
Zero.
So means what? You are accumulating 0 area because you are starting from the initial point and you are taking the initial point probability only. So this will be 0. What about this one? If you take x equal to plus infinity, 1, because the total area under the PDF has to be 1, because capital X has to lie somewhere between minus infinity to plus infinity. It has to lie, right? It cannot be means what you're talking about x ranging from minus infinity to plus infinity, means you are talking about all the possible values of capital X. So means x can be always be between minus infinity to plus infinity, so area has to be 1. So there are some properties of what CDF. CDF की property क्या बता रहे हैं अपन यहाँ पे, that since CDF is probability, so it cannot be less than 0. It can be 0, but it cannot be less than 0, because CDF is nothing but just a probability by the definition, and probability cannot be negative. Second thing is what? CDF cannot be greater than 1, because it's a thing, because when you take x equal to infinity, you can maximum get 1, because probability has to be 1. And third is what? Fx, when you take x equal to minus infinity, it will be 0. And fourth one is what? When you take fx equal x equal to infinity, you will get 1. So this is the thing. This is what the CDF means. So CDF is nothing but probability, and how the CDF is defined, that CDF is nothing but area under PDF. So it's area under PDF. It's area under PDF. Or CDF is integration of PDF. So PDF will be what? PDF क्या होगा? Differentiation होगा CDF का. Yes or no? Yes or no? Say something. Yes or no?
Yes, sir.
Okay. So this is what the defined as. This is for one random variable. For n random variable, I can generalize the formula that यहाँ पे बात कर रहे थे अपन x एक ही random variable था, तो x1 less than x. So same here also. This is by the definition can be defined as what? For n random variable, that probability that first random variable should be less than small x1, and up to nth random variable should be less than small xn. This is the definition of this, and you can write in terms of PDF also. So there are n random variables, so you will have n integration. Yes or no? You will have n integration or no? बोलिए, ज्वाइंट पीडीएफ है ना, तो n इंटीग्रेशन आ जाएगा. अभी पहले एक ही रैंडम वेरिएबल था, तो एक ही इंटीग्रेशन, तो बी n रैंडम वेरिएबल्स तो n इंटीग्रेशन आएंगे. एंड दिस विल बी व्हाट? माइनस इन्फिनिटी टू xn, minus infinity x2, minus infinity to x1. So there are n integration. So this is nth order integration, you can say, and you need to use joint PDF there. So that will be xt1 up to xtn, and this will be x1 comma x2 comma xn, and there will be what? N dx1 and dxn. So this is nth order integration if you have nth random variables. So this is called nth order CDF. It is called as nth order CDF. And how the PDF is related? Fairly simple. So it will be what? xt1, xtn, when xt1 takes small x1 up to xn, and this should be differentiation. So this will be partial differentiation. So nth order differentiation. So this will be capital N, and this will be dx1 up to dxn, and this will be the joint CDF. So this will be fx t1 x tn, and in bracket it will be x1 up to xn. So this is how this PDF and CDF are related. CDF is capital F, PDF is small f. So these notations are important, the meanings are important. So this is for one random variable, you can have for n random variable. So this is for n random variable, and if they are independent, then conditional PDF is same as the normal PDF or ordinary PDF. So conditioning का कोई यूज नहीं हो जाता है वहाँ पे, बस आपको ये लिखना होता है they are independent. If they are not independent, you have to go with this one. So independency simplifies our life, right? And joint CDF is defined by this one. So this is what, when you have infinite random variables, you will have infinite order PDF, you will have infinite order CDF, infinite order PDF and infinite order CDF. Can I take 2 more minutes and we'll just tell you about what is stationarity? I should wind up. Okay, we will wind up this, right? Today's lab, we will continue with this one, and I will upload this video and the lab video today only. So you watch those videos, and Saturday, 2 or 3 one or more 2 topics will be left, because in 2 hours I will try to finish all these things. And in the next 2 labs, that is tomorrow and day after tomorrow, I will take the numericals. So for numerical session, numericals you can watch tomorrow and day after tomorrow lab session. And for theory, today I will take theory only, right, in the lab. So this theory plus that theory, that will be 4 parts now till tonight. So 2 part आप at least देख लीजिए इस 2 दिन में. आप एग्जाम के दिन भी देखेंगे तो चलेगा, right? So I hope this is clear. You go with this independency and all those things. Again, you try to make some interpretation by yourself also, so it will be better, right?